Good morning, everyone. My name is Marcos Placona. I'm a developer evangelist for a company called Twilio. I think you may have seen a Twilio booth out there. Just out of curiosity, who doesn't know what Twilio is? Cool. So Twilio is a communications API that helps developers like yourselves adding SMS messages, voice like telephone calls, IP communication like chat, and video into the applications you're already building using the languages you already know. Today I'm not here to talk about Twilio, so if you want to talk to me about Twilio, you can come to the booth and I'll tell you everything about it. Today I'm here to talk about Android things. So here's some information about me. So there's my Twitter account over there, GitHub, and AndroidThings.rocks, which is the website I run about Android things. You will find all of the examples we're going to talk about today, except for one, and I'll tell you later about this. You will find them on my GitHub account, or there's going to be a blog post about it on the Android Things website. So it's all over there. You don't need to take pictures or anything if you don't want to, because it's going to be all over there. I will be publishing those slides later as well for you. Now, can I just maybe see a show of hands of how many people here did or do any kind of Android development? Cool, awesome. Okay, so a lot of the things I'm going to maybe half the room. So a lot of the things I'm going to talk to you today are going to be familiar to you. And this is the thing that actually excites me the most about Android things. Now, who's done any kind of IoT? Like, who's played with Arduinos or... Okay, so maybe another half the room. Cool. Some of the things I'm going to tell you today, you will be familiar with. Some of the other things I'm going to try and explain to make sure that you understand if you haven't looked at that before. Now, let's just kind of look at what Android things is, really. Because if you had an Android phone before, even if you've not been an Android developer, but you know something about Androids, you will know that up until now, you would get Android running on things like your phone, your watch, your TV, your car, maybe. But the idea here is that all of those things up until now, they had a display, they were pretty closed, and there weren't many ways for you to add things like sensors and everything. And the idea with Android things is you can now come out of all those things. You can now add things into your Android applications. You can now go and build your own things. You can build your own hardware. You can solder your own hardware if you're into it, but you definitely don't have to. So I'm gonna tell you a little bit about which ones are the applications for Android things, so things that have been seen out in the field, things that people are building with. So much like any kind of IoT stuff, you will have seen, you will see Android things being applied to things like cameras, points of sale, security systems, so people building security systems with it. And I'm going to tell you why building security systems with it is actually a good idea, as opposed to maybe building security systems with that Arduino you may have, or building security systems with that ESP8266 that you may have. There's also stuff like fleet management and asset tracking as well, because there's a lot of different sensors that you can use with Android things, and we'll talk about some of them today as well. Now, the thing that really excites me about Android things, and it's not something it's something that kind of like put me off some different hardware in the past, was Android things. All you need to run Android things is you will have your Android Studio, which if you're an Android developer, you already have. You will be using Androids with it, so you'll be using the Android API with this, and you can use things that you may have used in the past, such as things like Firebase, for example, or any of the Google Cloud platform products, or even, has anyone plays with Kotlin here? Is anyone excited about Kotlin? Okay. For the people excited about Kotlin, I will show you some examples in Kotlin as well, which is something that really excites me. Now, where does Android things run? Because I said, well, Android things doesn't really run on a phone. It doesn't run on a watch, so it runs on a different device. So where does it run? Right now, you have 4 boards, so you have an option of 4 different boards, okay? And mind you, those boards are developer boards, so this is why they're big. Obviously, if you were to build something more professional, if you wanted to have something on the field, you wouldn't end up with a board that looks like this, okay? You would basically just want to get this bit in here, which is the main processor, and that's where you can run it, and this is what would go on your professional boards. But there's obviously nothing wrong with trying to use one of these boards here. So NXP has done a lot of work towards getting Android things running on their boards. So you now have 3 different boards. Here's the average sorts of pricing you can get those boards for. The easiest ones to work with right now, if you're starting, are these 2, because they are developer boards. So as you can see, they have all these headers here, and we'll talk about those things. Now, I am going to tell you about my favorite board, which is the Raspberry Pi. There's a few reasons why the Raspberry Pi is my favorite board, and there's a few reasons why the examples I'm going to show you today will be using a Raspberry Pi. Okay? So the first reason is Raspberry Pi has a great community. Whenever and like any time I had any issues with my boards or any time I had any issues with using a Raspberry Pi, I was able to go into a forum, I was able to go into the Raspberry Pi community and find information about this. And when you are tinkering with something that you don't know much about or something that you haven't worked with, having a strong community behind it does make a massive difference, because it's a matter of minutes between you ask questions and you get a bunch of answers, and those answers will definitely help you out. So to me, it was very much about like avoiding frustrations, okay? I didn't want to be frustrated by, oh, but I'm using this hardware and it's got a bug in it or something, or maybe I'm not using it this way or the correct way. Now, the other reason for me as well was the cost, because Raspberry Pis, they are around 35 euros maybe. So buying a Raspberry Pi is cheaper than buying most of the other boards. So the cost was something important to me, because I am very happy to have a Raspberry Pi stuck to my door that does this one thing. But I'm not very happy, having like $150 stuck to my door. And when I say $150, I'm talking about buying a board that costs that much money, okay? So if you have something that isn't doing much, it's just doing this one job, and we'll talk about why they'll be doing this one job. You want to, like, I wanted to go cheap on that. I wanted to make sure that I wasn't putting a lot of money in my device and not using it. But then there's the most important reason why I am suggesting people use the Raspberry Pi here. It's inside your drawer already. I'm pretty sure you have one Raspberry Pi in a drawer just gathering dust because you saw the announcements, you went and bought it, and you did what everyone does. You just put it in a drawer and you forget about it. So most likely the Raspberry Pi will be already inside your drawer. And this is, this is good, because you can basically, if you have one, you can basically go home and you can start using. And I'll show you how to do it as well. I'll show you how to use it today. Now, how do you get started? So if you have a Raspberry Pi in your drawer, or if you get excited about this and you go and buy a Raspberry Pi today for when you come back, how do you get started? What do you need? Well, so obviously the first thing you need is a Raspberry Pi. The second thing you need is a memory card. So that memory card is basically where the software, so this is where Android things is going to be. So this is where it's installed. The next thing you're going to do is you're going to make sure that you have Android Studio, because that's where you will be building most of the applications. This is where you'll be doing most of the things to do with Android things, okay? Android Studio is free. You can just go and download it. You install it, and it will just work. And it's great like this. It will just run, and this is what I really like about it. No extra configurations or anything. Now, once you have those two things, you will go into the Android Things console. And so if you go to, if you just Google Android Things console, that's the easiest way to find it. You will find the setup utility. And the setup utility is it's basically a zip file that has libraries for installation of Android things. So no more, I'm going to download this file, I'm going to unzip it, and I'm going to put it in this place. Oh, I didn't put it in the right place. No more that, okay? And this is really important to me as well, because setting those things up and finding out that you haven't done it correctly or you missed a step or something can be very frustrating. With this, you just download the setup utility and you run it, and I'll show you how to run it as well. I will show you an example of how to run it on a Mac, but this runs on Windows, this runs on Linux. So anywhere, any kind of like machine you have access to, this thing will work. What you will do is you will have your memory card connected to your laptop, And once you have the memory cards connected to the laptop, you're going to go, in this case, I'm going sudo Android things setup utility, and I'm choosing which one I want. Okay, so I have a macOS version in there, and that's the one I'm going for. Next up, you will say, would you like to install Android things and Wi-Fi? Raspberry Pi 3s, they come with Wi-Fi, okay? Obviously, the I in IoT is important here, so you want to make sure that you have internet. So I'm going to go ahead and say 1. So I want to set up the Wi-Fi. If you miss that step, it's fine, because you can set this up later. So next up, you will go, what hardware will you be using? And this is one of the important bits, because you want to say, cool, if you're using an XP Pico or something, you want to choose number 2. In this case, I'm using a Raspberry Pi 3. Now, you've chosen your hardware. You will click Next, and it will go, cool. So you've chosen the Raspberry Pi 3. What do you want to do? This is super cool. So do you want to install a default image, or do you want to install a custom image? Much like Linux, you can have custom images on this, and it totally makes sure to have a custom image when you are deploying this to the field. So say you now came up with a product that you want to deploy, and you want to put it in a bunch of places, you might want to have a custom image, because your custom image will come with things like all of the applications you need. It will come with the Wi-Fi configured. So it's basically a pre-configured image, much like what you would do with like an Ubuntu custom image, for example. I am going to go default image here, because we just want to start from nothing. We want to start from 0, okay? Later, you can start with the default image, and you can dump this image and say, this is now my custom image, and I'm going to deploy it to the other devices I have. So I'm going to choose number 1 here. And that's when it's going to go and download Android things. So it downloads the CLI, it downloads everything for you. You don't need to do anything. It will ask you to select the drive, and the drive is basically your memory cards, and it will go ahead and download. So it will flash the drive and everything, and it will do the validations and everything for you. And at the end, you should be good. So this is telling me, would you like to set up the Wi-Fi on this device? And now, I just showed you an example of how to install it, and it was really quick. You would just see the whole thing going really fast. This doesn't go as fast, okay? And I'll tell you this. When you start installing this, my suggestion is when you press Enter, when it starts installing, go get yourself a coffee or something, because it will take a while. I say it will take a while. It will take about 20 minutes, okay? Because it will download everything for you, and it will take about 20 minutes. Now, how do you know it's installed? Because at the end, you will end up with a screen that looks like this. So if you have your Raspberry Pi connected to a screen, the Raspberry Pi has an HDMI port. So if you have it connected to a screen, you should see this. And if you see this, you know you now have Android running on your Raspberry Pi. You now have Android things running on your Raspberry Pi. But you shouldn't really just take my words for this. I'll show you a quick demo of how Raspberry Pi actually runs on a device. I have a device right here. So I'm mirroring my screen, and I'm gonna go into my IDE. Let me just make sure I'm not cheating here. So I'm gonna start from 0. I want to start from an empty project for you. Just so I can show you. So this is a vanilla project. This is a Kotlin project that I created in Android Studio. I didn't want to create the projects in front of you, because there's no point. I just went File, New Project, and I chose Kotlin, but that's it. So this is a vanilla project. Every single time you create a new project in Android Studio, this is what you're going to have. You're going to end up with something like this. Now, some of the things that you will need to import in your file. The first one is Android Things. Android Things right now is in version 1.0. So that's the version you're going to want to use. Second thing you're going to do is, if you are using any drivers, and we're going to talk about drivers later, but if you are using any drivers, then this is where you can import. Drivers are basically just like libraries, okay? Very much like if you're an Android developer and you bring retrofit into your application, like when you bring an extra library, drivers are the same idea. So I'm going to go and bring the button driver in here. And that's it for the configuration. Then you have your manifest. If you've done any Android or Java, you know you always have a manifest file. In my manifest file, the only thing I'm doing is I'm saying, I'm using the peripheral I/O. So I want to get access to the inputs and outputs on this Raspberry Pi. I'll show you how to use the I/O in a minute as well. Now, let's just make sure that we are really indeed connected to this Raspberry Pi. I'll write a very quick dump of the GPIO, of the I/O ports on the Raspberry Pi. So I'm going to create a new variable here. I'm going to call that service, and I'm going to use the peripheral manager, and I'll get an instance of it. And I'm just going to log that. What are the I/O ports I have in this device? So this is all I'm going to do first. So I'll go service.getGPIO-list. Now, if I click the green button here, it will show me what options I have, okay? Much like when you're doing any kind of Android development, it shows you what devices you have. And if you can't read that, this is the only thing I can't zoom that. If you can't read this, this says Google IoT Raspberry Pi 3. And it's running on Android 8.1. So it's running on the latest version of Android. So it's already recognized my device that is connected here. I'll click OK. This will do its magic, so it will go and compile it and do its thing. And once it finishes compiling, we should see something at the bottom there, which you can see here, which says BCM10, BCM11, BCM12. So this is my GPIO ports. These are all the GPIO ports I have in my device. Okay? We're going to look at how we can use those GPIO ports as well and why they're important. Cool. I'll come back to my slides, and then I'll come back here later. Now, this was just a backup in case something didn't work. I had a video backup, so I'm going to skip it. But yeah, so far, we have been hardware-free. So I've been telling you about GPIO. I've been telling you about sensors and everything. And granted, if you have done those things in the past, if you have used any kind of hardware like this in the past, you will know what those things is. But I thought I'd maybe give you like a hardware 101. I'll just tell you a little bit about hardware and a little bit about which hardware we'll use and what they're for. Now, the first thing is, I've been talking about inputs and outputs. So if you've never heard about GPIO, like GPI what? So GPIO. General purpose inputs and outputs. You have a Raspberry Pi here, which is very similar to the one I'm using here, the one I just showed you. You also have all the pins and all the ports, which are these, okay? So this is what they are. These are the names and everything. And you can see stuff like BCM5, BCM12. So those are the GPIO. So those are the general inputs and outputs ports that you get on a Raspberry Pi. There's a bunch of them. There's a bunch of power lines as well. So you have your plus 5 volts here, 3.3 volts. You've got your ground, and you've got a bunch of different things that you will use or you may end up using if you plug sensors to your Raspberry Pi. Each one of them has a different purpose. So you have stuff like SPI, for example, which is a protocol. Some sensors will use SPI because it's a fast way of communicating. Anything that has BCM in it are just plain general purpose inputs and outputs. So those are plain GPIOs. Now, the other things you are going to see and the other things you're going to see today are breadboards. So breadboards are basically, I kind of describe them as a non-committal way of prototyping stuff, okay? Because whenever you start building anything with electronics, you look at people soldering things and everything. Well, soldering is like, you can't reverse that. Unless you desolder it, you can't really reverse it. So if you're learning and if you're trying to really get started with things, breadboards are what you're going to use. And once you're happy with them, if you want to turn them into a product, then it's cool. But you can move into the soldering part of it. But the breadboards are basically, the idea of breadboards is you have those jumper wires here. You basically just plug them into these holes, and you will be able to use the lines on the breadboard. Jumper wires is what I just said. So if you want to go from a sensor to a breadboard, you can use a jumper wire. So no soldering here. The next thing you will see is you will see things like resistors, for example. So resistors are basically a resistance, much like what your shower has to control the current. So this is like to control the currents that goes through your circuits, okay? So if you were to think of this, like an analogy of this would be, if you get a 120 volts light bulb and you put it in a 220 socket, that light bulb will explode. It's the same idea with this, okay? So you will use resistors to make sure that that voltage and that current goes down. One important thing that I learned when I started doing IoT was the colors actually matter, okay? So my first time using resistors, I was like, oh, that's really cool. They're all colored, so I'm going to color code now. The colors on them actually matter, and this is basically how you tell the resistance that you want to pass through. And you will see a lot of LEDs as well. So this is like just an example of an LED. You have an anodes and a cathodes, much like a light bulb, much like what I just talked about in the cathodes. And the one thing about LEDs is, yes, they make things bright and happier, so you're going to want to get a lot of them. Because when you get LEDs, you can build stuff like this, which is pretty cool. So this is an LED cube. It's a 4x4 LED cube. Now, the other thing you are going to see is you're going to see stuff like this. So you will see some of these schematics that look like this. And this is using a free tool called Fritzing. And Fritzing, you can just go and download it. It runs on Windows and Mac. And it runs on Linux as well. Fritzing is basically a great way for you to not only do your prototyping, like think about how you want to build something, but to also share. So you will notice that most of the blog posts I told you about on AndroidThings.rocks will have those kind of schematics in there. So if you want to try and repeat it, I don't need to tell you connect green wire to blue wire. Like this is not bomb diffusing stuff. So I can show you something like this, and it will be much easier for you to copy. So it's almost like copy and pasting, except that the pasting is manual. Now, I showed you this example here. So this is a button which has a resistor connected to it. It's connected to power, and it's connected to one of the pins. And I'll show you a demo of it. So I'll show you how a button actually works in Android Things. I have a camera connected to my laptop, which is not showing anything for some reason. So let's just see if I kickstart it. Okay, I'll open the software again. Yeah, so in here you can see my camera. You can see this is live. So you can see I have a Raspberry Pi. The Raspberry Pi is connected to a breadboard. There's some jumper wires going around it, and there's a button right here, okay? So what you're going to try and build is just a very simple button, like something that I can click on. So we'll go from the same example that we've used before. I'm going to create a new variable here for a button, and this variable will be of type button. Now, if you have used Android in the past, you see that Android.widget is basically what you've been using for buttons. You just get Android.widget. Right now, because we've imported the driver for button, we have another option here, which is the com.google.android.things. This is the option you want to choose, because we're not using a widget here. We're using a button. We're using a physical button. So we're going to choose that option. Now, much like any kind of new objects that you create, we will initialize this button by calling the button library, and we'll say where this button is connected to. So in my case, I know my button is connected to BCM5. So this is the pin my button is physically connected to. And I'm going to decide what is the logic state for this button. And when I'm talking about logic states, is I want to say what happens when I press the button and what happens when I release that button. So we'll choose that the logic states here will be pressed when low. So you had a pressed when high and pressed when low. Pressed when low is when you push it. Pressed when high is when you release it. So we'll go with pressed when low. And then I am going to just set an event listener for this button. So the event listener, much like any other button, is what happens, like what should happen when I press that button? What do you want it to do? And what I'm going to do in here is, instead of logging every single time the application starts, so logging the GPIO list every single time the application starts, I am going to log just when you press the button. So let me change this to say GPIO. So what should happen in here is, instead of this application starting and us showing this at the bottom, this application will start and we will do nothing with it. Nothing will happen until we press that button. The other thing I'm going to do is I'm going to say button.close when the application starts. So this is just so that button is not left hanging. Like you wanna close this object. Again, I'm going to run this application, press OK. And you should see that as soon as that blue bar stops, it installs the APK. And now I have nothing. Like I don't have anything. I'm going to clear this. I don't have anything. So this didn't really do anything because I said I only want something to happen when I press the button. I'll bring up the camera here for you again. And what should happen now is when I press this button here, you should see a message at the bottom. And there you go. So like whenever I press the button, you see a message at the bottom, and you can do this multiple times as well. So this is the basic button. Like this is like sort of where you start when you're learning this thing, and you're like, okay, I want to make sure that this works how I expect. We'll look at more examples in a minute. Again, I had a backup for this in case it didn't work, so it's doing the same thing. So I'm going to skip the backup. Now, what have we done in here? We've done a few things. So the first one is we have used the com.google.androidthings.gpio. So we've used the GPIO in our application. The other thing that we've also done is we've used a driver in our application. And remember in the very beginning when I said, cool, I'm going to bring Android things into this application on the config file, and I'm going to bring a driver. So this is now when we're going to talk about drivers. What are those drivers? Like, what are they for? Drivers are basically your way of talking to all the external devices you have. So basically your buttons, if you have any kind of sensors, if you have GPS, if you have accelerometers, that's your way of talking to them, okay? So there's no need for you to build your own driver if one already exists. So much like what you do in the Arduino world, you can just download those libraries into your application, and those libraries will basically take care of all the communication with the hardware. There's quite a few drivers out there. So you have, like I said, you have drivers for buttons, you have drivers for servos and sensors and like LED displays, you have drivers for all those things. But you will come to a point, just like I did, when you need to go and write your own driver. And this is also possible, okay? Because if you have done Androids, in the past, you will, it's totally possible for you to go and write your own driver. I am not an electrical engineer, okay? So it took me a while to understand how datasheets work and everything, and what is the useful information I can take out of it, but it's totally doable. So someone actually wrote a blog post about how to write your first Android Things driver. Totally doable, totally easy to do. Now, why did I have to write my own driver? Because I had this project in mind, which is I wanted to create a binary clock, okay? Now, as you can see in a binary clock, you have a bunch of LEDs in here. So this is lines of different LEDs, and you want to be able to control all these LEDs. You want to make sure that you have enough GPIO to control the LEDs, and you want to make sure that your clock doesn't look like a mess. There's not a bunch of wires coming out of it and everything. So I wanted to find a smart way of controlling my binary clock, and the way I found this was I found this thing on the internet, which is called the Mac 7219. And the Mac 7219 lets you control up to 64 LEDs. So things like if you want to think about, like if you want to build your own LED cube or something, you're going to use something like this. You're going to want to use something like this. You can also chain them. So not only you can control 64 LEDs with one of these things, you can chain it, and now you can control 128, and you can carry on doing it. So I think you can chain them 5 or 6 times. So this gives you like a lot more input and output. However, what I found was, cool, this is a great piece of hardware, but there was no driver for it. So I had to go ahead and build my own driver. Like I said, I'm not an electrical engineer, so it took me a while to go and learn how this driver works and everything. But it was like, I felt like I accomplished something when I did this. This is open source as well. And the beauty of Android Things is I can collaborate this to the Android Things community. So now, whenever you need to control 64 drivers, 64 LEDs, you can just go and get this driver, because I built it for you. So Android Things really, in my opinion, it really enforces the whole idea of open source, of helping each other, and I really like that with this kind of drivers. Again, I wrote a blog post about this, so there's all the information you may need about how I created this driver, how to use the driver, and everything. Now, and there's some URLs at the bottom here, as you see, so if you want to go check them out. So this is the URL for this blog post, so bit.ly 64-LEDs. Now, what of those things are managed by Google, and what of those things are not managed by Google? Because I told you Android Things is like Android, but it's running on a different device. But there are things that you're not going to have, because there are things that you don't need in Android Things. Some of those things are launchers, for example. You don't have a launcher in Android Things because theoretically, you don't have an interface. You don't have a phone. You don't have messaging. You don't have contacts, because this is not a phone. Like, it's not meant to work like a phone. It's meant to work like a piece of hardware that you can use to control other things. Because of that, displays are optional. And I really like the idea of displays being optional, because, again, if you're going to have this running on a field, say you're a beekeeper and you want to keep control of like the temperature on your hive, you really don't need something like a display in there. You can have that piece of hardware feeding data to somewhere where you actually have a display, but you don't need to have a display connected. Whereas up until now, if you did anything with Android, a phone comes with a display, and that's it. Like you have no way of like going out of it. So Android Things, like most of the examples, actually encourage you to do things like use joysticks, for example, or use things like sensors, or use voice commands. And this is really cool, because like it moves you away from I'm just using a phone and I'll control it. It moves you away from that, and it makes you be more, to me, it made me be more creative about the things I was gonna build. So voice control is like a super cool thing to build. I don't know about you, but like I get excited about controlling a piece of hardware with voice control. So that's really cool. However, if you want to use a screen, like I said, there's an HDMI socket on a Raspberry Pi. So if you want to use a screen, you can do it. If you want to get one of those Raspberry Pi screens as well, you can use it, and it will just work. Okay. Now, how about we look at a different demo? So something else that I built, and I'll tell you a little bit of a story here of why I've built this demo. I work from home. Okay. And my thing about working from home is I don't like working from the office, because working from the office is like I get distracted. I'm always talking to people. There's always a lot of noise and everything. But I am much like this when I work from home. Like I have my music very loud. It's the music I like to hear. It's not the office music. It's the music I like to hear. And I listen to it very loudly, okay? It will either be coming out of my speakers or coming out of my headphones, but I am always listening to music. And what happens is when I'm working from home and I'm listening to music, this is what my mailman will look like when they try and ring my doorbell to deliver me a parcel. And this happens all the time. I get a note through my door saying, hey, we tried to come over and deliver you a parcel, but you weren't home. I was. So I I decided to think about this in a different way because I was like, well, I'm always home. I'm always in front of my computer, and I always have my phone in front of me. Wherever I am, I always have my phone in front of me, okay? So I thought, well, mailman comes over, rings my doorbell, and I don't hear it. Why is it I don't hear? Because it's just a noise it's just another bit of noise in the house. So I was like, can I build something that will let me hear the doorbell or let me know there's someone at the door, even though I'm actually not looking at that? So that's the thing I built. So I built the smart doorbell. And this is my own version of a smart doorbell, okay? What it does is whenever the mailman comes into my house, they press the doorbell, I get a call on my phone. Now, I'm going to try and demonstrate it to you, and hopefully this will work. I'm going to go back to I'm going to go back here. So this is a different project I have. Okay, so this is my doorbell project. The basic idea with this is I am using Twilio to call my phone. So I am using a serverless function inside of Twilio to call my phone. So I just make an HTTP request to it. This example is in Java as well. So I wanted to show you that if you're not into Kotlin or if you're not using Kotlin and you want to do this in Java, you can do this in Java as well. So this example is in Java. Just like before, I have a button. I have the doorbell API. So the doorbell API is basically what my API looks like. Okay, so this is my endpoint, right? So it just gets generated for me. This is what my dependencies are like. So I have Android things again. Like I said, I have button. I have retrofit. So retrofit, if you've not used that before, retrofit is basically just a library that helps you making HTTP requests. So then in my codes, I instantiate. So I create a new retrofit object. I pass in the URL. So the URL is basically the URL the serverless function I want to call that will make a call into my phone. I do all the initializations and everything. So I'm just saying I want to use the button. I want to use that on BCM5. So which is the same ports I have used in the past. I'm setting an event listener much like I did before. And my event listener is here. So as you can see, when I did it in Kotlin, it was like a 3-line kind of thing. This is more of a 30-line kind of thing. But it's the same concept, okay? I go and I create a call. So I create a new call object. And I just make a request to that URL. And at the end, I just go and close everything, just like I did before. Now, one thing that is important to know with Android things is it's not meant to work like your phone works. Like you're not meant to have a bunch of applications running on it at the same time, because especially if you have applications running on it that use the same inputs and outputs, you're going to have conflicts in there. Because the applications, they're going to go into backgrounds, but they have the inputs and outputs configured still. So they're still running. So you're going to get conflicts in there. What I usually do is I just make sure that I uninstall, and yeah. So I just make sure I uninstall all my applications, and I only have one application running at a time. Like the idea is not that you have multiple applications, but the idea is that you have multiple devices if you need, but not multiple applications running at the same time. So I'm going to install this. And you'll see that when I install it, not much will happen because, again, this starts up and it's like, OK, I'm ready for you. Like, I'm up, I'm running. But unless you do something, unless you press a button or something, I'm not going to do anything about it. I'm going to show you my camera again. I'm going to bring it next to my phone. I'm going to put the ringer up on my phone. So this is how it should always be. And what should happen in here is when I press this button, I should get a call on my phone. So we'll try that now. And hopefully my phone will ring at some point. Yeah, so oh, here we go. So when my phone rings, I not only I want to see that, but I want to know what's going on. So I get a...
Buddy at the door.
So I get a voice saying there's somebody at the door. So you can use different numbers and different things. You can put different messages and everything. You can make it ring different people. You can use a camera in there. And like, in fact, the way I did is, I didn't want when I started building this thing, I was like, I want to make it really obvious to the mailman that they should press the button on the doorbell. So I bought a massive arcade button, like a red, big arcade button, and I put it in front of the door. And guess what? The mailman never pressed that button. Because it's like, why would you press a massive red button? Like, is he going to throw buckets of water on me or something? Like, why would I do that? So this was my mistake, okay? So version 2.0 is when I did it like this. So I went and changed my doorbell. I changed the way my doorbell works. So instead of just sending the signal to the thing that is inside, it just talks to my Raspberry Pi, and that's much more friendly to my mailman. So that's, again, that's one lesson learned for me. Now, I also have some honorable mentions, okay? Because building IoT, like, I'm not a... I only started with IoT a few, it's maybe a couple of years ago or so. So building IoT stuff is a kind of a new thing for me, but I like to make it about fun as well. I'm all for doing professional things like my doorbell, but I like making it fun as well. I like thinking about it as a fun thing to do. So some of the honorable mentions of the things I built. I built the Highfive machine. And the idea with the Highfive machine is every single time, so not that, but every single time I get a new follower on Twitter, so I have this thing on my desk, and every single time I get a new follower on Twitter, I've got a hand that goes and high-fives me. Now, the reason I built that is, first, I wanted to see how responsive Android Things was, and how responsive to external actions it would be. So I built something that looks like this, okay? So I have a Twitter action. The Twitter action in this case is new follower. You can have a Twitter action for likes. You can have a Twitter action for replies or DMs. So the Twitter action in this case is I get a new follower. That whenever I get a new follower, that creates a new that makes a request to a Firebase function. That Firebase function then triggers something on my Raspberry Pi. So I'm going from my Twitter account into the Raspberry Pi that is on my desk, okay? And the way you kind of do it is you have a database, you have a Firebase database, and that is what is orchestrating. So that's what's sending signals into the Raspberry Pi that is on your desk, and the Raspberry Pi on your desk is just waiting for things to come in. So building stuff like this for fun is cool because you learn a bunch of new things. I had not used Firebase functions up until that point. I had used different functions, but not Firebase functions. So it was cool because I actually learned a different thing that I didn't know about. Controlling office lights. I have Philips Hue in my office, and while I can very easily just say, like, Alexa, turn the lights green, or Alexa, turn the lights blue, I wanted to prove to myself that I could do it with buttons as well. So this is like basically going against what Philips Hue does in using the app. So I just wanted to go analog in this case. So I had a set of buttons here, and what this does is much like my doorbell. What this does is it calls the Philips Hue API. If you have Philips Hue at home, you have the API running. So it calls the Philips Hue API, and if I press red, it turns red. If I press green, it turns green. Now, again, this is documented. There's a blog post about this you can find. Now, the last thing I want to mention is something that I've built a couple of weeks ago, and it's important to me because it's something that I've been wanting to do for a while, and that one doesn't have a blog post yet because it's very new. So you're basically kind of the first ones to see it. Does anyone here play Magic the Gathering or played Magic the Gathering? So, I have been playing Magic the Gathering for about 20 years now. I started playing Magic when I was very young, And with time, I just went and I accumulated a lot of cards because you buy them and then you find someone selling their collection on the internet and you buy that too. And you go to like a draft and you go to like a tournament or something, you win it and then you get more cards and you just put them in boxes, like you just do that. So these are boxes of cards here and here and here and piles of cards and everything. And you get to a point where you have like 5,000 cards or something. So the one thing I really wanted to be able to do with my cards was, if they're the expensive ones, I will know about them. But if they're like the uncommons, they'll probably be on a pile somewhere. Many times I ended up buying the same cards I already had because they were in a pile and I didn't know about them. So I wanted to find a way to catalog them. Cataloging them would mean, well, I could either do this manually, just like going one by one and typing the names or something, having like an Excel spreadsheet or something, or I could do it in a way that I didn't have to do anything. Like I could build something, I could like automate it in a way, and I could build something and it will do all the cataloging for me. So come the magic sorter. So that's a thing I built a couple of months ago. It is rough, as you can see. It's not a professional thing. It's very rough. But the idea is you have a cradle here, which is where you put your cards. You have a servo in here, and you have a couple of Lego wheels. So I wanted to build this with Lego because I didn't want to go and commit into like 3D printing or anything. Maybe one day I will 3D print this thing, but I wanted to build this in a way that it was very easy for me to move things around. And Lego actually happens to be great for this because you make a mistake in here, you take that piece and you put another piece, and like you know, it's very easy to move things around. So I built a cradle that has a stack of magic cards. The wheels are here. Then I have a small servo here that basically holds the cards, and I have a camera in here. So if I zoom in on this, this is what it's going to look like. Okay, so I have my cards in there. One card slides down. So the servo here turns. One card slides down. The other servo here holds it. When that servo holds it, I know that servo is holding it because I have a light sensor at the bottom here. My card covers the light. So whenever it covers the light, I know there's a card placed in there. So that's when I know to go and take a picture of it. When I take a picture of it, I send it to Google Cloud Vision. And Google Cloud Vision, if you haven't used it, it's great. So I send it to Google Cloud Vision, and that does an OCR for me. So it reads what's on the cards. So it kind of works like this. So I've got my magic cards, then I take a picture of it, send it to Cloud Vision, and then I send it to Firebase. So not only now I'm cataloging everything in a Firebase database, but because I'm also using the Magic API, so there's a Magic the Gathering API, so because I'm also using the Magic API, I know how much those cards are worth. So if I have a bunch of cards and I don't really know how much they're worth, or like I don't really know, Magic cards, they change values as well. Like they may be worth nothing now, and in a few years they're going to be worth a bunch of money. So if I don't know how much they're worth, then I can go and look in this database. Okay. So the next step. So this is what I haven't built. So maybe if I come back next year, I'll tell you about the next step. So the next step is I'm actually going to build a companion app, which I can see on my cards. So I'm actually going to build an Android app that I can look on my phone, and I'll be able to see all my cards in there. So I'll be able to scroll through them, look at the prices and everything. So this is super exciting for me. Now, I kind of want to close, and I'm going to leave some time for questions as well, if you have any questions. But I kind of want to close with so it's the power of Android. So it's the thing I already knew. So this is why Android things was it was appealing for me, because it's the thing I already knew. It's managed by Google, okay, because you can even having my devices at home, I can send over-the-air updates to it. So if I decide to make an update to it, I can send over-the-air updates to it because they're all connected to Google Cloud, and it's automatic and secure because deploy either you deploy to the device yourself or you do over-the-air updates. With that, I have been Marcus Placona. There's all my information in there, my GitHub account and everything that you may want. And thank you very much. Now, does anyone have any questions? Yep. It's Raspberry Pi 3 and 3B+ only, so it doesn't support the older versions, and it doesn't support the Raspberry Pi Zero, which breaks my heart because the Raspberry Pi Zero is very small. And I asked the Android Things team at Google about this, and they told me the Raspberry Pi Zero doesn't. Like the specs on it aren't enough to run Android Things, which is a shame because like I would love to have a smaller version of it. Now, the other thing that is worth saying as well about Android Things is, much like Android, it runs on Linux, okay? So it doesn't do anything that is super time sensitive, like it doesn't do real time, for example. But it's not an Android thing, it's not an Android limitation, it's a Linux, like Linux doesn't do real time. So if you need to do anything that is real time, that won't happen. You can very much just use the same things you use in Android. So the same, and not to pitch on my next talk tomorrow, I'm actually going to be talking about Android security tomorrow. But you can apply the same things you can apply on regular Android app, you can apply to this. All the same things. Anyone else? Cool. I will be around. I'll be around here today, the whole day. I will be here tomorrow as well. And I'll be at the booth. So if you want to talk to me about Android things or Twilio or anything Android, I'll be around. Thank you.